Hello students, so let's continue with the MCQs of chapter 10 Gravitation. The first MCQ for today is two objects, here 2 is not clear, two objects of different masses falling freely near the surface of moon would, there are 4 options here, have different accelerations, undergo a change in their inertia, have same velocities at any instant, experience forces of same magnitude. If you look at the first option, have different accelerations. We know that these objects of different masses, we have seen in the previous video that when objects of different masses fall freely near the surface of Earth, or in this case it is moon, they would have same accelerations. So in this case, acceleration will be due to gravity of moon, but they will have same acceleration. So first option is wrong. Second is undergo a change in their inertia. We know that mass of a body measures its inertia. So inertia itself is not a physical quantity, but mass of a body measures inertia of a body. So undergo a change in their inertia means undergo a change in their mass, which is not possible here because when a body falls freely near the surface of moon, its mass would not change. So inertia would not change. Have same velocities at any instant, and the last option is experience forces of same magnitude. Let us look at the fourth option first. Experience forces of same magnitude. We know that they will experience force of gravity due to moon. So that will be weight of a body on the moon. So two different bodies, since they have different masses, so their weight, which will be equal to mg. M1g, M2g, where g will be acceleration due to gravity of moon. So since their masses are different, their weights will be different, and hence they will experience forces of different magnitudes, not of same magnitude. So first, second, fourth options are wrong. Let us look at the third option. Have same velocities at any instant. Now students, let us consider moon here. Two bodies having masses m1, m2. Let their initial positions be a1, a2 respectively, which are at the 2 points are at same height above the surface of moon. So if the two bodies are falling freely, and let us assume they are dropped from these 2 points, so then we know that their motion will be uniformly accelerated motion. In this case, it will be acceleration due to gravity of moon. So at any point, let us consider after some time, the M1 body is at B1 and position and M2 body is at B2 position. We are assuming that they are dropped from A1, A2, which are at same height above the surface of Earth at the same time. Simultaneously, they are dropped. So at time t or after time t, they will be reaching at the 2 different points which are again equidistant from the surface of moon. And since both the bodies are having same acceleration, uniform acceleration, so their velocities at B1, B2 should be same. In fact, at any instant during the motion, their velocities will be same because they have same acceleration due to gravity of moon. Now let me just clear one point here, students. Now it is not mentioned that the different masses are falling freely. They are falling freely near the surface of moon, but they have not mentioned whether they are falling freely from the same height or from different heights. Okay, so when they are falling freely from the same height, even from different heights, then also in both the cases after time t, if they are falling freely from different heights or same heights, but after time t, if they start their motion simultaneously, then after time t, they will be having same velocities at any instant. So at any instant means at any instant during the motion, during the free fall motion, they will be having same velocities. This is due to their uniformly accelerated motion. And we are assuming that the different masses are dropped. Okay, so it means their initial velocity is 0 meter per second. So it is 0 meter per second for each of the two bodies. So I hope it is clear to you, students. So third option, have same velocities at any instant, is the correct option. Now the next MCQ is, the gravitational force between two objects is F. If masses of both objects are halved without changing the distance between them, then the gravitational force would become, 4 options here, F by 4, F by 2, F 2F. So let us try to solve it quickly. Now let F be the gravitational force of attraction between two bodies, each having masses m1, m2. Let R be the separation between them. So by Newton's universal law of gravitation, F is capital G m1, m2 over R square, where capital G is a constant of proportionality called as universal gravitational constant. Now, the question is, what would happen to this force if the masses are halved? So what we have done here, see, let us assume the new force will be F dash when the masses are halved. So writing m1 by 2 instead of m1 and m2 by 2 instead of m2 and keeping R same, we get F dash is equal to this. After doing simplification, we get F dash is equal to G m1 m2 over 4R square, and that will be equal to 1 by 4 G m1 m2 over R square, but G m1 m2 over R square is F. So F dash is 1 by 4 times F. So it is F by 4. It means the gravitational force becomes 1 by 4 times F if masses of the two bodies are halved. So A, F by 4 is a correct option. Now this is a knowledge-based question. In the relation F is capital G m1 m2 over d square, the quantity G, capital G, I've already told you this in the previous MCQ. We know what is this capital G now. This expression is a mathematical form of Newton's universal law of gravitation, according to which the force of gravitation between two bodies is directly proportional to the product of their masses and inversely proportional to square of the distance between them. And G is a constant of proportionality called as universal gravitational constant. And we should know that G is called universal gravitational constant because its value is same in the universe for all the bodies, for all the media in which the bodies are placed. So out of the 4 options, as we know G is a universal constant, so 4th option is correct. It is G, capital G is universal constant of nature. The last MCQ is, the atmosphere is held to the earth by gravity, wind, clouds, earth's magnetic field. You have done the chapter, your concepts are clear. You know that the reason for this atmosphere is held to the earth is Earth's gravitational pull, and we call Earth's gravitational pull as gravity or force of gravity. So A, gravity, is the correct option. Hope students you have understood the MCQs. So we'll continue with more MCQs in our next video. Goodbye students.